Good morning. Today let us see the analysis of bars of varying section. So here you can see the section 1 made of some material. L1 is the length, A1 is the cross-sectional area, A2 is the cross-sectional area of section 2, L2 is the length, and A3 is the cross-sectional area of section 3, and L3 is the length. It is subjected to an axial force or load P. How to find the stress in section 1, section 2, section 3, followed by strain and followed by the total change in length. So stress in section 1 is equal to load P by A1, area of section 1. Strain is nothing but E1 is equal to section 1. Stress in section 1 divided by E, or stress is equal to load by area, so P by A1 into E. Similarly for section 2, stress in section 2 is equal to P by A2. E2 is equal to sigma 2 by E, or P by A2 into E. So sigma 3 stress in section 3 is equal to P by A3, and strain in section 3 E3 is equal to sigma 3 by E, or P by A3 into E. So total change in length is equal to dl1 change in length in section 1 plus change in length in section 2 plus change in length in section 3. So dl change in length formula is PL by AE. So for section 1, PL1 by A1E plus PL2 by A2E plus PL3 by A3E. So the total change in length. So as P by E is constant or common, I have taken outside, and since all the members are made of same material, so I have taken E as common outside. E is constant, so L by L1 by A1 plus L2 by A2 plus L3 by A3. So if each and every section is made up of different materials, let us say E1, E2, E3 for the sections respectively. So dl is equal to P into L1 by A1, E1 plus L2 by A2, E2 plus L3 by A3, E3, as E is different. Next, we'll go to the principle of superposition. When a number of loads are acting on a body, the resulting strain, according to principle of superposition, will be the algebraic sum of strains caused by individual loads. While using this principle for an elastic body which is subjected to a number of direct forces, tensile or compressive, at different sections along the length of the body, first the free body diagram of the individual section is drawn. Then the deformation of the each section is obtained. The total deformation of the body will be equal to the algebraic sum of deformations of the individual sections. Now let us take the sections like this, three sections of different length and different cross-sectional area. It is subjected to different loads in different directions, P1, P2, P3, P4. Suppose while solving the problem, sometimes three load values will be given. If they ask you to calculate any one of the force, first we need to write down the equilibrium equations. That is, sum of the left hand side force is equal to sum of the right hand side force. That is, P1 plus P3 is equal to P2 plus P4. With this equation, we can find any one of the unknown force. How to find the total elongation? Now let us go to the free body diagram of the individual section. So this is section 1, this is section 2, section 3. Okay, let us assume this as length L1, length L2, length L3. Okay, section 1 I have taken free body diagram. Okay, section 1, and P1 is the force acting here at the section 1. The same force must act on the right hand side also for equilibrium. It is under tension T. And now the third section, P4 is the force acting on the right hand side. Same force it must act here on the left hand side for equilibrium. Again it is under tension. If you go to the middle portion, P2 dash, okay, let the force acting on the section to left hand side P2 dash, and here P3 dash, P2 dash is equal to P3 dash. P2 dash is equal to P3 dash, and P2 dash plus P1 will be equal to P2, and P3 dash plus P4 must be equal to P3, and this is subjected to compressive force C. Now how to find the total change in length dl is equal to dl1. dl is PL by AE formula. Here P is nothing but P1 into L1 by A1 into E. Here why I am getting negative means compression minus P2 dash into L2 divided by A2 into E plus third section force is nothing but P4 into L3 divided by A3 into E. That's nothing but will give you the total elongation of this assembly. Thank you.